This answers the standard I can describe and calculate capacitance. This is question 58 from chapter 24. Several 0.25 microfarad capacitors are available. The voltage across each is not to exceed 600 volts. You need to make a capacitor with capacitance of 0.25 microfarads to be connected across a potential difference of 960 volts. So A says, show in a diagram how an equivalent capacitor with desired properties can be obtained. So I said because it's in series that 1 over capacitance would be just added up like 1 over C1 plus 1 over C2 plus 1 over C3, dot, 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 dot. And in parallel, it's the equation is equivalent is C1 plus C2 plus C3. So we didn't want it in parallel, we wanted it in series. So I just made sure to have enough capacitors in series so it didn't exceed the 600 volts. So since there's 3, I had 960 divided by 3, which is 320. And that checked out because that's not over 600. And then in B it says no dielectric is perfect insulator and that would not permit the flow of any charge through its volume. Suppose that a dielectric in one of the capacitors in your diagram is a moderately good conductor. What will happen in the case your combination of capacitors is connected across 960 volt difference? So if it acted as a conductor, then it's not acting as a capacitor, in which case there would be only 2, which it seems to me like it would still be okay, because since I had 3 in the first place, and instead of 3 having 2, that would be the 960 divided by 2, which is still smaller than the 600. So I don't think anything bad would happen, but if I'd done it with 2 and then one of them had turned into a conductor, then that would have exceeded it, and I'm sure there's a technical term for it, but I think something bad would have happened. I don't know, I could guess at what it's called, but it would exceed the 600. The voltage would exceed 600, and that'd be bad. I tried to look it up, but it seems like the bad thing I'm talking about would be called a short in the circuit.